Hello everyone, this is Jonathan, BD from BlenderDude.com. Today's video is actually a remake of one that's been available on the site for some time now, YouTube as well. It is my noise comparison video. I got plenty of positive feedback on the first video. A lot of people wrote in and told me they found it helpful. I've subsequently come to learn, however, both through my own research as well as with the help of some comments on my YouTube channel, that the information I was putting out, while not perhaps entirely inaccurate, could have been misinterpreted. So if you're familiar with the way I do these comparison videos, I do try to take a somewhat scientific approach to them. However, the driving force behind all of them is always practicality. I want the information contained within them to be of practical use to you, so that you can simply take it, plug it into your own formula or set of criteria that you're using when you're making your buying decision, so that it will actually prove of some value to you when you're making your selection for the right high-performance blender for you. And so although the information that you will get from this one, if you happen to see the first one, will not be wholly different, I just want to make sure that we are being as accurate as possible in what is actually being conveyed here, so that that will in turn translate to a more practical use for you. In short, what I was doing was taking a decibel meter reading of each of these blenders as they ran, and showing you the readings. We were coming to conclusions that because one decibel reading was higher than another, that therefore translated into one blender being louder than another. And truth be told, when it boils right down to it, that is probably the case in almost any situation. The higher the decibel reading, the louder the machine. But what that decibel meter is actually conveying is not loudness. Sound is actually emitted in waves, and those waves are picked up by a meter either in intensity or in pressure. With this decibel meter, it is picking up the intensity of sound waves. Now you can take that reading, and using mathematical formulas, when you're comparing two objects that are making noise, you can translate eventually which one is louder than the other. But it's not as simple as just taking the meter, taking the readings, and therefore extrapolating that one machine is necessarily louder than another. There's a lot of variables that go into play in coming to that conclusion. So if you've read various reports on the internet that blender A is 20, 30, or 40% quieter than blender B, that very well may be the case, but to come to that conclusion, you have to have a very specific set of circumstances under which those conclusions are drawn. What you're blending, where you're blending, how tight are the walls in your kitchen, where the location of the meter is when it's taking the readings. All those come into play when you are forming conclusions like that. So although they may be true, those reports that you've read may be true, they are highly subjective. And the bottom line is, what's going to be of most practical use to you when forming these conclusions is how loud do these machines sound to you? That's going to be probably as legitimate a test for you as anything else. So today what we're going to do, we are going to run the blenders again. I'm going to let them run for 20 or 30 seconds each to let you hear through the microphone of the video camera how loud they sound to you. I will also take a meter reading again and show you those results. However, unlike the first video, what I'm going to do today is, instead of taking the reading from around the blender, or in other words from around the source of the sound, I'm actually going to hold the meter in the approximate location of where your ears might be while you're using each respective blender. That again goes back to practicality. It doesn't really matter how loud the blender is at its source. It matters how loud it is where you're hearing the sound, or where you're picking up those sound waves, and that would of course be your ears. So I would anticipate the results to be the same, in that the loudest blender from the first video is probably going to be the loudest blender in this one, but I would expect the meter readings to be slightly different. And you can take those readings and do whatever you want with them. You can go ahead and figure out the math behind that, and draw your own conclusions as to exactly how much louder one blender is than the other. But the real practical point of the video will be for you to just listen and pick up as best you can any differences that you perceive through the microphone of the video. One thing I do want to mention also that I didn't in the first video is, if you are going to do the math to compare the differences in decibel readings from one machine to the other, make sure that you're aware of that the scale in which you're using to draw these conclusions is not a linear scale. Decibels are actually compared to one another on a logarithmic scale using a base 10. The long and short of that is, without breaking it down into the minutiae of the mathematics behind it, is if, for instance, one object is making noise at 40 decibels and another is making noise at 20 decibels, that first object is not twice as loud as the second. A difference between 40 and 20 decibels is actually 100 times as intense as the lower reading. So that just gives you an idea of the kind of information that might have been misconstrued from the first video, and we're going to try to avoid that here. So what I'm going to do today is the same thing I did in the first one. We're going to run the blenders using the same ingredients. We're going to run them on the same, or approximately the same speeds, i.e. the high speeds on each machine. I'm going to make some spinach cubes that I will freeze and use for my green smoothies at a later date. The ingredients are simply fresh spinach, water, and that would normally be all I use, but today I'm also going to add some ice so that we can try to create as much noise as possible in the blenders while we run them. And I will just run each one for, again, 20 to 30 seconds to give you an idea of how they sound. I'll show you the decimal meter readings, and that will be the extent of the video today. So let's go ahead and get started. I'm going to load the containers first. And I believe as long as we're using the same ingredients and running them on the same speed, this should be a fairly comprehensive and legitimate test. Just going to add one handful of baby greens. You can use any greens you want: spinach, kale, chard. I've seen people using dandelion greens before. Whatever you want. The great thing about this is if you don't have fresh greens on hand, by doing this in advance, putting these in your freezer, once they harden in a Ziploc bag, you don't have to have fresh greens on hand in order to make a green smoothie. And that's the whole point of what I'm doing here today, in addition to the noise video. Alright, I'm going to add exactly 2 cups of water into each container. It really doesn't matter how much water you use when you're actually making the spinach cubes. Anywhere from half a cup to a cup and a half is probably going to be fine. And I would normally actually add more greens to each container than just one handful. Two cups in the Pro 750. And we'll get 2 cups in the 5200. Okay, bear with me while I grab my ice. We'll put exactly 2 cups into each one as well. And again, the whole reason I'm adding the ice is just to create some more noise. Get our lids on. I'm not going to need the tampers today for any of these machines, so I don't have them handy. Okay, here's the meter we will be using. I'm simply going to hold the meter again at the approximate location of where you would be standing, or where your ears would be if you're standing in front of the blender, and I'll show you the meter reading for each one as you listen to the blender run as well. We'll start with the Omni 5 and work our way across. Registered at 88.2 decibels. Here's the Blendtec Total Blender. I'm going to run this on high. 94 decibels with the Total Blender. Here's the Pro 750. This would represent any of the next generation Vitamixes that you're looking at. .5 decibels for the Pro 750, and on the end down here is the 5200, which would be representative of any of the traditional Vitamix models that you're considering. Okay, so once again, the OmniBlend 5 registered at 88.2 decibels. The Blendtec Total Blender registered at 94.4 decibels. The Vitamix Pro 750, 87.5 decibels. And the Vitamix 5200 registered at 90.1 decibels. If you have any questions about what you've seen today, or any other questions on high-performance blenders, by all means write me at bd@blenderdude.com. or visit me at blenderdude.com or my YouTube channel and ask any questions or post any comments you have there. Until the next video, this is Jonathan. Have a great day. Hello everyone, this is Jonathan, BD from blenderdude.com. Today's video is actually a remake of one that's been available on the site for some time now, YouTube as well. It is my noise comparison video. I got plenty of positive feedback on the first video. A lot of people wrote in and told me they found it helpful. I've subsequently come to learn, however, both through my own research as well as with the help of some comments on my YouTube channel, that the information I was putting out, while not perhaps entirely inaccurate, could have been misinterpreted. So if you're familiar with the way I do these comparison videos, I do try to take a somewhat scientific approach to them. However, the driving force behind all of them is always practicality. I want the information contained within them to be of practical use to you so that you can simply take it, plug it into your own formula or set of criteria that you're using when you're making your buying decision, so that it will actually prove of some value to you when you're making your selection for the right high-performance blender for you. And so although the information that you will get from this one, if you happen to see the first one, will not be wholly different, I just want to make